So we want to compute another integral, the integral of e to the t cosine t dt. So if we look at this integral, we can't really see any immediate ways of figuring out what the antiderivative is. So we can go through our tools of integration and see if anything helps. Substitution doesn't seem to be able to work because e to the t and cosine of t don't seem to have derivatives that are immediately useful to us. But it is a product of e to the t and cos t, so we can see if we can use integration by parts to help us. So first we can set u equal to cosine of t, just to see if this works. So now the derivative of u is just negative sine t dt. We have dv equal to e to the t dt, and v equals e to the t. And just for a reminder, we'll write down the formula for integration by parts again. So if you have an integral that is in the form of u dv, then this is equal to uv minus the integral of v du. And hopefully this second integral is going to be easier than the original one. So if we write this out, then what we're going to get is cosine of t, e to the t, minus the negative sine t et inside the integral. So it's going to be plus the integral of e to the t sine t dt. So right now, we seem to have an integral that's equally tricky. But let's see if we can do this again and get somewhere. So right now, we want to make sure that things just don't all randomly cancel out. Because if we get this integral that's positive on the right-hand side, then everything will cancel out and it won't be very helpful. So what we want is this sign to be negative when we do the integral of v du. So we'll try to get w equal to sine t, dw equals cosine t dt, and I'm just using different variables because we already used our original variables u and v. So just for clarity, we're just using different variables, but it's the same thing. It's integration by parts. So dx is going to be e to the t dt, and x is going to be e to the t. So if we continue on, we see that we have cosine t e to the t plus sine t e to the t minus the integral of e to the t cosine t dt. So as you can see, this is the exact same as this integral here. So if we let this equal to I, then we can just move this over to the other side to get 2i. So if you differentiated the wrong term over here, so if you differentiated e to the t instead, this might be positive, in which case everything will cancel out. If that happens, then all you have to do is go back and differentiate the other term to see if that works better. So this is the same as negative I. So if we have I equal to that, then we can just move this to the other side. So we get 2 times I equals cosine of t e to the t plus sine of t e to the t. So if we divide both sides by 2, then what we get is I equals cosine of t e to the t plus sine t e to the t divided by 2. And this is the indefinite integral of this integral. And don't forget plus c.